Hey there everyone, I hope you're rocking today. Lately, I've been asked about machine learning and artificial intelligence in the geosciences. The potential is there and being harnessed as I make this video, but I think there are two considerations that have to be integrated and understood for machine learning and artificial intelligence to be unleashed properly on the geosciences. Before I get going, if you have any questions or any concerns or anything you want me to talk about, just leave them down below. Let's get rocking. Hi there, I'm Dr. Chris, a professional geoscientist. The future of geoscience and arguably almost everything in the world lies in machine learning and artificial intelligence. Now, personally, I don't like the term artificial intelligence, so I'm not going to be using it much for the rest of this video. For machine learning, the bigger the data set, the more samples, the better the observations, the more types of data, the more ideal analysis ML will produce. The geosciences, and seismic in particular, generates huge volumes of data with tons of samples. This means seismic, at the very least, is poised to harness machine learning. Further, remote sensing, satellite imagery, LiDAR, drone imagery, and geoscience go hand in hand. Surface geology, ecological systems, land movements, chemical and biological processes, water levels, canopy cover, temporal changes of these over large areas. Put these in combination, simulate them, temporally alter them, invert them, or dig into unseen attributes. This is the realm of machine learning. Now, before we can even get to this point, I think there are two barriers that are currently hindering ML in the geosciences. The first has more or less been overcome. The second, not so much. Before I talk about them, let's look at some statistics. As reported by Forbes, 68% of companies in multiple industries are actively working on a roadmap to machine learning. Perhaps only 11% are already harnessing ML. Unless Skynet comes along and blows everything up, this implementation number will simply continue to rise. As pointed out by a study in Science, machine learning is now a general purpose technology and replacing specific kinds of jobs which require mapping well-defined inputs to well-defined outputs. If your geoscience jobs consist of identifying things such as salt domes, faults, stratigraphic changes, or even evaluating inversions, AVO analysis, synthetic models, all of these are arguably well-defined inputs and outputs. That means a machine is poised to do that work for you faster and better. It's time to learn to code. Now, back to the barriers I spoke of before. The first barrier. First, you listening? First, is compute power, which I believe has been overcome sort of in the geosciences and pretty much almost anything else at this point. Two words: cloud computing. You no longer have to use a computer in your office, the server in your computer's server room, the big server in the server room, your company's processing facilities in another country. Obsolete. You want to light up 10,000 processors, 100,000 processors, 1 million processors, bit of an exaggeration right now, on Amazon Web Service or Google. The problem right now in geoscience is, as of making this video, software hasn't been created to conquer seismic processing in cloud computing. But there are some very smart cats working on it right now. Get on board. The second barrier is the need to acquire way better data than we have access to right now. You've heard of the saying, you can't polish a turd. Well, I would now add to that, you can't machine learn a turd. For land seismic, in most parts of the world, we have the cathode ray tube view of the Earth. The video's okay, it's a little bit out of dimension, maybe a little out of focus, it's prone to static. It's definitely old technology, low energy, low resolution. You can use machine learning on that if you want pointlessly better cathode ray view tube of the Earth. Putting lipstick on a pig, that's machine learning to low resolution seismic. No, new seismic data has to be acquired to fully sample the wave field using more and better geophones, more and better sources for ultra-high fold and massive trace density through better seismic planning techniques. To maximize machine learning, we simply need the 80-inch 4K or better TV of seismic data. This data doesn't quite exist yet, but I can foresee machine learning knocking the out of it once it has been acquired. Those were my thoughts on what is needed for effective AI and ML in the geosciences. We are partway there with the near infinite scalability of cloud computing. We just have to acquire way better seismic data, especially in land, to make AI and ML worthwhile. Thanks for watching. If you like this video, please give me a big thumbs up, subscribe to my channel, add me to your LinkedIn, or even better, share my videos through your networks. Till next time, I'm Dr. Chris. Keep rocking.